Okay, so if you are doing questions like these, or most often when you're doing questions like these, you'll find that um, people don't like to be simple, and situations aren't always nice and clear cut. A lot of the time, there are difficulties or constraints that come up whenever we're doing these situations. When those come up, we deal with them first. So in this particular case, we're going to be dealing with people. And obviously, if you're dealing with people, and if you know anything like what it's like when you're dealing with students, there's always going to be situations where such and such can't sit with such and such because I don't care why. It's just there's always something. So when we have those, we will deal with them first. And then deal with the ones that aren't any difficulties at all. So when you're doing the calculations, it's much easier to do that. So 8 people form 2 queues. Albert will only stand in the left-hand queue. Beth will only stand in the right-hand queue. Charles and Diana insist on being in the same queue. So in how many ways can the 2 queues be formed? Now, you'll notice that we haven't mentioned all the people. We've only mentioned Albert, Beth, Charles, and Diana. There are 4 of them. So they're the only 4 we need to work out. So let's start with Albert. Okay, we're going to start with him and work out, what's his problem? How many different spots can he stand in? Well, if he'll only stand in the left-hand queue, he'll only stand in that queue. He only has 4 spots. Beth is similar. She will only stand in the right-hand queue. And that means she only has 4 spots as well. Next ones, we've got Charles and Diana. They insist on standing in the same queue. So how many different ways or how many different spots can he be in? Well, realistically, let's say I've got that's not on. Let's say we've already placed Albert and we've already placed Beth. So we're doing them in order because we're now placing them. So now I get to Charles. Charles doesn't mind if he's in this queue or this queue. He doesn't care. Okay, as long as he's in the same one with Diana. So let's do Charles first. Okay, well, Charles can be in any of these spots. So Charles has 6 different spots he can be in. Okay, he can't be in the spot where Albert is. He can't be in the spot where Beth is, but he can be in any of the other 6. Okay, so that's cool. That's Charles is done. Now Diana, she is insisting on being in the same queue as Charles. Okay, so how many different spots can she actually be in? Well, let's say Charles is here. If that's Charles, then Diana can only be in one of those 2 spots. And if Charles was up here, then she could only be in one of those 2 spots. So with her, with Charles already chosen in one of them, Diana's only got 2 spots in that same queue because they need to be in the same queue. So that's how many spots. So it doesn't matter which one we choose. Let's say it's Charles and Diana. Okay, it doesn't really matter which one they are. And then we've got the rest of the people. How many different spots can they be in? Well, there's 4 spots for each one of those. So we have 4 factorial at the end there. So any one of those 4 could be in that one, 2, 3, or 4. The next person could be in that one, or that one is 3. The next person could be in that one or that one, which is times 2. And the next one could only be in that last one, which is times 1, which is why the rest of them get 4 factorial. So what we end up with, we're still using the multiplication principle, but now we've dealt with all these constraints that we had first. We got rid of them, and now we've got 4 times 4 times 6 times 2 times 4 factorial. So you've dealt with all the problem ones, and then you've dealt with the last one, and that equals 4,608 different ways that those 2 queues can be formed. And that's only with 8 people and with 2 queues. Pretty cool.